Here you go.
Okay, so in trying to understand why the platinum glowed in Davy's experiment, what we have here is I've simulated a wire for you that has electrons flowing through it. So it has a current. Current refers to a flow of charge through something. And in our case, it's going to be a flow of negative charge or a flow of electrons that is passing through this wire. Now, if we took a section of this wire out and replaced it with something that was either a different material or perhaps it is of a smaller diameter, it is going to have a different resistance. And resistance is going to refer to how easy or difficult it is to pass a current through a certain material. So if we add in a piece of material here in the center, if we put in a new section of wire that has a higher resistance, meaning it's more difficult to get to the electrons to flow through this section, okay, that's what's going to create our incandescence. So if you imagine, let's say you're coming down the E-wing and you're heading up to the 3rd floor, or you're heading across the E-wing to the F-wing, and you come to that junction where everything, you're talking, everything's going well, walking down the hallway, and then bam, everything just slows down to a stop. Okay, you have entered an area of a lot higher resistance. It's a lot more difficult, takes a lot more work to get through it. Okay, and that work is going to produce heat. And so trying to push this flow of electrons through this narrow space or less conductive material is going to create heat. And so essentially it's going to glow. It's going to get very hot, and objects that glow or emit light due to an increase in temperature, that is what is meant by incandescence. And so that is why his platinum glowed, because it reached such a high temperature and to the point that it actually melted. Now, let's see what this looks like in an actual light bulb. All right, so we've got our power source here. We've got our chemical reaction taking place in the battery, which has created a difference in charge from one side of the battery to the other. So we are, by connecting this circuit, this is a simple series circuit, which creates a path for electrons to move from the negative side to the positive side of the battery. Electrons are going to be flowing in this direction. Flowing, flowing, flowing. And then when they reach here, this is called the filament. Okay, when they reach the filament, this is a section of wire that is going to offer a higher resistance. And so when electrons pass through this portion of the light bulb, it's going to glow red hot. And that's what we see when we turn a light bulb on. When current passes through the filament, it glows red hot, and that emits a light from that heat, and essentially that's what lights up the room. Now, they aren't the most efficient. They tend to give off roughly 10% of the energy produced by incandescent bulbs is going to be in the form of light, while 90% of it's going to be in the form of heat, which is why you want to make sure that you've turned off your light and that it's cooled before you handle the bulbs, because they're going to get pretty hot. The evolution of the light bulb has gone through many different types of filaments. We started off with, I believe it was platinum back around 1807. Then we tried some charcoal filaments in the mid-1800s, but those tend to make the bulbs charred and very cloudy, which is counterproductive. If the outside of this light bulb turns black, not a lot of light's going to get out. And then Thomas Edison, in 1879, came up with this idea of creating high resistance filaments inside the bulbs, which here are filaments, high resistance filaments that are able to withstand very high temperatures without burning up, and that would offer quite a bit of resistance, so they could offer quite a bit of light in the form of incandescence. Then in 1911, with the invention of tungsten wire, we have the tungsten filament. So again, the tiny wire that is inside, we later learned that by coiling this wire, we can increase the surface area and the distance the electrons have to travel, creating even more resistance, which is creating even more heat, which is offering off even more light. But these are the same types of filaments that we use today. So today's standard incandescent light bulbs that you see in your home that look like this are going to have that tungsten filament inside them. Here's one that's a little bit older that you can probably see the filament inside. Now notice that the glass itself is kind of tinged and it is darker at the top than it is the bottom. I took this out of my old china cabinet, and as the heat rises, it tends to darken the inside of these bulbs, depending on what's on the inside. We used to just suck all of the air out because we don't want oxygen in, because remember we learned that oxygen will just fuel the fire. That's going to cause our filament to burn up. Instead, we take all the gases out. Around 1912, they started filling the bulbs with nitrogen or argon, some type of gas that having the gas itself would exert pressure on the filament, allowing for it to be more stable under higher temperatures and kind of hold everything together, while also keeping the outside of the bulb from charring. Now we notice this bulb is white. This has actually been coated with silica, and the silica is going to filter out about 3 to 5% of the light. So they're pretty efficient as far as how much light they allow to go through, but what it does is it allows through a greater spectrum of light to give us kind of a fuller array of colors in the room. So those are nice. And brings us to our incandescent bulb. Here's just 3 picture examples. This is the bulb turned on. Notice we have the power that is going, the electrons flow up one terminal across the filament, in which they are greatly raised in the filament's temperature raises and producing heat, and then back down the other side. So here's one that is off, so you can kind of better see the filament inside. And if you notice, when you if you have a light bulb that's burnt out, and sometimes you take it out and you shake it, you'll see that the little wire is broken. And if the electrons can't flow all the way around back down to the positive side of the battery, then they stop flowing, and so therefore we don't have any more power inside the bulb. These are our incandescent bulbs. Incandescence is the emission of light due to an increase in temperature. Basically the idea that hot things glow. Campfires glow, lavas glow. If you see an old blacksmith hammering on something and the metal gets really hot, it glows. It gives off light, and this is one way the technology has harnessed that phenomenon and brought light into a dark world. All right, that's it for today, campers, and we'll see you on the next installment of maybe the compact fluorescent.